Good morning, everyone. I guess we need a few more rounds of coffee or espresso, what have you. So welcome to the very first panel of the Supply Chain Security Summit. I always say software security is really the very first in the supply chain security. So it is appropriate that our first panel is about software security, integrity, and transparency. You all are aware of the presidential executive order that was issued in May 2021 about the improving nation's cybersecurity. One of the sections of that EO explicitly addressed software supply chain security. And it actually pointed out that because software is vital to performing various critical functions, and the commercial software development lacks sufficient focus on the ability to resist attack and lacks of transparency and also inadequate controls to prevent tampering. Ever since that EO, we have seen increasing degrees of awareness of software supply chain issues. And to a large degree, thanks to our experts as our panelists, like those sitting there, who have championed for software supply chain security. So I am really thrilled to have three distinguished leading experts in this topic area today with us to share their insights with us and to, in fact, talk about some of the hot topics that people, the community is concerned on the software security. So with that, I would like to invite each one of our panelists to give a brief introduction of themselves. I actually think you probably know them all, but still. Let's start with you, Allan.
All right, pardon me. Good morning. I'm lucky enough to actually know most of you in this room, which is very exciting. I'm Allan Friedman. I'm the guy who doesn't shut up about SBOM. About a year ago, I moved over to CISA to help sort of scale and operationalize work that began at NTI in the Department of Commerce. And happy to chat about SBOM and where it's going in the short run at CISA and maybe some different futures that we're going to have to decide between.
Okay. Thank you, Allan. And Brian?
Hi, good morning, everyone. Thank you, Wen. Thank you, MITRE, for hosting this great event. Look forward to the day of learning here on supply chain security. At Microsoft, I work on a variety of different projects. My background's actually in microelectronics security, but more recently been focused on the supply chain aspects, and happy to be here today to talk about some work that's being done in the Internet Engineering Task Force around standardizing some of the end-to-end supply chain activity.
Thank you, Brian. And now Mike.
Thank you, Wen. My name's Mike Worden, and I think I represent, we'll say, industry in this case. I would list myself primarily as a practitioner of supply chain risk management. My current role is tech director of Raytheon's cyber testing facility. We test all their internal products and services, as well as those products and services of our customers. over the past few years, like many of the folks in this room, we're struggling with the practice of supply chain risk management. And as we go through and address that, my insights will be more on the tactical level. How do you address some of the fundamental challenges of, embedded malware or software that is not designed for the use case that it's been deployed in. So I'm very happy. Thank you for the opportunity to sit on stage with some of the folks establishing the standards that I've used for some of these years.
Great. Interestingly, predating the EO, back in January 2021, MITRE published an article on software supply chain, where we proposed an end-to-end framework for software supply chain integrity. There were 3 components in our article. The first one calls for managing risk through standardized SBOM. And the second one calls for improving code and component signing infrastructure. And the third component calls for hardening the software build and distribution infrastructure. And I think you will hear from our distinguished panelists today on various aspects of those as hot topics. So without further ado, Allan, would you like to talk about the hot topics with regard to implementation of SBOM?
Sure. So I think most of us are pretty familiar with the idea of SBOM, right? It's a dependency graph, and Chuck did a great job of talking about it and giving an overview, as well as some of the reasons about why to do it. And of course, we've got the basics of it. Where we are today is that there is no reason why any organization that has, non-trivial security or maturity cannot start producing SBOMs based on their software, asking for SBOMs from their suppliers, and beginning to consume them. I don't want to overstate where we are in terms of turning SBOM data from data to intelligence to action, because that's the goal of all of this, is to actually drive something. We're learning about that. There's some very basic, easy use cases for SBOM, right? Is there anything in this supply chain that maps to a list of, I love Chuck's term, known badness, right? So we can do that, but there's a lot more fun work that's going to happen. I think it's okay that consumption is lagging a little bit, right? Until quite recently, very few people had SBOMs. And so as more and more people start to play with this data, I think we're going to see a huge influx of innovations and small businesses and research projects. So I think that's great. At CISA, I'm going to sort of briefly cover what we're working on in the short run at CISA, and then we'll talk about, just very briefly, what the longer term looks like. So CISA, we're trying to sort of help amplify the scaling and operationalization and interoperability of SBOM data. So we've recently launched 4 work streams, one of them focusing on cloud and SaaS. Most of the discussion around SBOMs is really focused on on-prem software. It's on my network, I need to know what it is. Very few people have come to me over the last years and said, Allan, the future of software is on-prem, right? Clearly that's a Microsoft's wager as well, right? They're betting the farm on just on-premise. We need to tell some better stories about what SBOMs mean, right? If you had Salesforce's SBOM, what would you do with it? I think there are some very useful stories to tell across the entire ecosystem, but we need to be more explicit about that. And we also need to talk a little more about the operationalization of SBOM for things like third-party API calls. Right? So if I'm using a service that calls another service that calls another service, pretty soon my SBOM is just going to be the entire internet. So we need to sort of think about what this looks like, scope. So cloud, second, tooling and implementation. If we're not able to do this through automated tools at scale, we will fail. And frankly, that's true of any security discussion that we're having in 2022, not just SBOM. Our our goal is to help bring together the tooling community, both commercial and proprietary tools and open source tools, and say, hey, are these interop the way that we expect them to? We certainly want to encourage competition and innovation, but if we want a world where two tools look at the same piece of software and produce pretty similar results, we should verify that assumption. And thinking about, right, what does this model look like? So cloud, tooling. Third one, which I think we're going to talk a little more about, is sharing and exchanging SBOMs. This isn't unique to SBOMs, but today we don't really have a way of moving metadata around at scale, especially across a complex supply chain where it goes from, value add to value add to value add. Right now, the best thing we have is portals, company portals, and those don't really scale, especially if you're trying to deal with like large organizations and you want access control and things like that. And then the final piece is sort of on-ramps and adoption. How do we make it easier and cheaper to move forward on software transparency? And how do we make sure that the SBOM work is coordinated with what's happening around the world? And CISA is playing a role on our side, working with other governments. So that's the short-term stuff, the potentially a hot topic. But the sort of controversial thing that I want to throw out to start the discussion going is sort of the potential notion as we begin to build on this idea of SBOM. So the basic model of SBOM is quite simple. It is just, right, here's a minimum set of data that we need to be able to understand what's in my supply chain so I can map it to other sources of data. That was developed by a community as a simple model for, I think, two reasons. One, because we didn't, right, there was enough pushback against the idea that we should have any transparency whatsoever, that we should, like, let's build this model as simply as possible. But the other approach is following the classic principles of modular architecture, of saying, let's do this and then link the data to other things. And so one vision of the future is we stay in that modular architecture model, and that has two potential directions. We have a modular model that succeeds in linking to other sources of data, and it just becomes a wonderful wide web. And that means having some interoperability and some good other types of metadata across the ecosystem. That's the success story. The failure story of the simple SBOM is, yeah, we have the basics, but we never quite figured out how to link a simple SBOM with some of the other data that we're talking about. And that, I think, has real benefit to the supply chain, but it doesn't give us the multiplicative power. Now, there are also some other fun efforts by very smart, very well-intentioned people to say, you know what, let's add a lot more data into this, into the SBOM itself. Rather than creating other pockets of data and other data formats that we link, let's, since we're collecting the data and we're building the tools, let's build some much broader, richer data sets that will still, we can call them SBOM or we can call them something else. I don't want to quibble about the semantics. So this is your build tools and vulnerability data and the full-on detail of who touched everything. Now, this is without a doubt something where we want to head from I want to track more data. But if we build everything together, we have two futures again. The optimistic one is we've built this successful, rich, standardized model that can now accomplish a lot, and it's all in one place. The risk of this approach is we've all seen the world littered with really great standards ideas that no one ever touches because they were too complex and they were trying to cover too broad a world. SBOM's power is that it can apply to the entire world of software, which is giant, right? That's everything from the modern cloud native container to the blinking box that's keeping grandpa alive in the hospital to the radio access network that's going to shape our 5 and 6G networks. So complexity delivers value, but we all know enough to know that complexity is the enemy of security and success. And so as we think about where we want to go, there are risks to every path, and I just want to sort of understand that, and I think that both of these gentlemen can be able to build on that.
Thank you for that, Allan. I think we can wait till later during the Q&A to explore some more on those points. So, Brian, your hot
Great.
topics.
Absolutely. Thanks again. And thanks, Allan. Great intro. So I'm here today to talk about an IETF standard called Supply Chain Integrity, Transparency, and Trust, or SCIT. And really the goal of this initiative is to develop a fundamental architecture and building blocks and API to really start describing how we manage this data for compliance for end-to-end supply chains. And a good way to start thinking about this is kind of just to consider the general case of a supply chain kind of across 4 personas. And so the first one being really a policy manager. This would be a person who is responsible for really gathering those requirements, internal or external, and developing the supply chain policy across the value chain such that at each point you can have gating factors in terms of whether you are in compliance or out of compliance. Producers are essentially those entities that are building the goods and services, but also creating evidence along that value chain. Auditors, this does not have to be a person, certainly could be an automated system, but they are going to map that policy to what is generated from the evidence and describe, again, is this in compliance or out of compliance? And then finally, the deployment or the consumer that's going to receive that final product, they're going to want to have visibility back upstream. That may be just looking at a conformance statement based on the audit, or that may be diving deeper into looking and uncovering some of that evidence that was collected through that value stream. So a key output really of this effort is to promote interoperability around this management of data and to really simplify and automate the workflow. And we're just really getting started with the working group in the next few weeks. So we would welcome anyone to join, be a contributor, be an observer, and participate in helping us define this standard more. You can just build out the slide entirely, that's fine. So I'd like to credit Bob for allowing me to share his slide. He was an initial member of the SCIT team here at MITRE. And so what's laid out in the middle is essentially a software development flow that we're all familiar with. The SCIT instance, in this case, is represented on the right. And there's effectively 3 components here. One is the ledger itself, and this is an append-only structure that has a couple of elements to it. One would be the signed evidence itself, those elements falling out of the software development cycle that we want to store, SBOM being one of those entities. The other element here would be the policy. Again, what are those gates that we want to enforce along the supply chain as we build our software? So for SBOM, for example, if you look at the beginning of the build stage, as an input gate there, we're evaluating third-party IP SBOMs, for example. And then as an output of the build stage, we're generating an SBOM. But as you can see from the amount of just notional evidence there and notional gates, we're collecting a lot richer data sets than just the SBOM itself. And so collecting these and having these in a ledger that's available for interoperability across a value chain creates some interesting opportunities for additional analytics. And keep in mind, this is just a picture of the development flow. If you kind of look downstream and start thinking about deployment from a consumer perspective, you would have a very similar picture where you would be pulling in this package, pulling in an SBOM, potentially looking at upstream claims and evidence, but then also perhaps having your own internal policies that you want to apply. And do my internal policies match what's been delivered? Or do I need to do additional verification and validation testing? Do I need to do additional vulnerability scans? And maybe I create my own ledger entries for my internal consumption and deployment of this product. And of course, this builds upon itself. And as Allan mentioned, as you start expanding this out to larger systems at an enterprise IT level or cloud architecture, you really start to have a very robust and large model that you can start to reason over. So hopefully this gives a taste of kind of the scope of what we're looking at from this IETF standard. And of course, as mentioned earlier, we'd welcome contributors to this and look forward to the ongoing discussion. Thank you so much.
Thank you, Brian. Let's transition to Mike with his hot topic.
Sure. As I said in the opening, I focus on the practice of supply chain risk management. And my focus, is built on the experience of, we'll say, the past few years of actively doing testing. Supply chain risk management is, for my organization, not an abstract exercise. Raytheon, like other aerospace contractors, focuses on flight safety equipment, on weapon systems, critical systems that protect our nation. It's getting it right has ramifications. Getting it wrong has ramifications. And so, and we're struggling with the challenges, the classic challenges of software-based supply chain risk management. The first being one of transparency. Certainly an SBOM starts to cast light onto what comprises any particular software package. Complexity. You've already addressed one of my concerns of the standard getting far more complex than it needs to be. Simple allows you to move fast. However, the other challenge is the point in time problem. I'm gonna pick on my Mac because there's a Microsoft guy on the stage, and picking at Microsoft is just a little bit too easy. Last night, while I was in the hotel, my Mac decided to update to the latest greatest version of Mac OS, and as I was thinking about sitting up here, it illustrated a point. What are the adds and deletes onto the SBOM of my MacBook Pro as a report, as a function of that particular update? How does that change the nature of the system? A very common problem that gets posed to my organization is we have designed this system that is doing something important. It could be again, satellite system, aircraft system, something. And we just discovered that there's a component from China, or a software package that's open source that came from a country that we currently don't have a great relationship with. Is that should we be worried about that? And as a testing organization, it comes down to maybe yes, maybe no. I focus on the test rather than the point of origin, generally speaking. Many of it was easier several years ago when most of these agencies were focused on waterfall-based technologies. They baselined their software systems, moved forward, and there was some degree of consistency over a period of years. If I flash back to the slides that we just saw, what I saw is a standard DevOps pipeline with an implied continuous integration, continuous deployment model. The answer that I might give you on Tuesday is not the answer that I could give you on Thursday. And that challenge of being able to give a good answer and be able to attest to the areas of security, is challenging to me. So from my standpoint, the hot topic would be, how do you automate this so that we can, so that we can respond at the speed that software is evolving? First off, how do we translate some of this abstract data, including an SBOM or any other attestation, into useful information so that you can make an accurate risk assessment as to whether this software is suitable for its intended function?
Thank you, Mike. Maybe I can push this discussion a little bit further on the attestation and testing aspects, right? So SBOM, in its simplest implementation, as Allan was pointing out, right, provides metadata, allows us to see what's in the software package and where it comes from. Testing, typically, somebody talked about testing earlier and asked the question, to our keynote speaker. Testing quite often is focused on functionality of that software package. So we're talking about security here. How do we then, given those information, identify security holes? Can any attestation and such kind of functional testing help us to get to that point?
You want to go ahead with this?
I'm
You're the
sorry.
test expert. Yeah.
I'm stuck with the mic, I think is a, well, let me, from a practical standpoint, as a security engineer, we're never certain. We're only, we focus on the burden of truth. And all of the components that you just mentioned help us to get to a, we'll say a burden of truth. Is the software well designed? There are automated tools to help us assess that, code coverage, source code analysis. Does it, functional tests? The model, the standard DevSecOps model includes, a functional testing aspect for all of the components. And that evidence does weigh in the decisions. Fuzz testing, by its nature, starts to give you an indication of how the software behaves under non-standard conditions by design. And the challenge, typically my answer on all of these cites that particular piece, that as a chain of evidence. What we've not had to date, but is on the horizon now, is to be able to look at that continuum of how we can predict how the software can behave. In other words, if there is hypothetically a ledger that describes the composition of the software as a function of time, and correlates that to good behavior or acceptable behavior, you then get to a better risk decision. Conversely, if your equations are overly complex, you are stuck in what's known as analysis paralysis here. A complex system. I'll pick on I work a lot with satellite networks. Command and control network or something like that literally has hundreds of software packages that are put together in a particular fashion. Standard CVEs don't necessarily give indicators because they describe a general use case, and this is a very specific use case. You can go down the rabbit hole of focusing on that instead of using it as an indicator. So from my standpoint, from a testing standpoint, it tends to be less, the answer is never cut and dry. It is, it comes down to a risk analysis. Here are some of the risks. A typical answer is when we analyze this supporting library, we see, several concerning things that represent an attack surface. Here's some things in your deployment model that you should think about to supplement the security that is not present in the software package. The answer is how do you define security? And the answer has to be one of defining security as a relative scale for the function intended.
I want to start sort of 3 points to make. Start by picking up on a point that Michael said, which is, hey, CVEs are a general risk, and that's very different from the specific risk of how a piece of software is actually deployed. In fact, if you go to some of the commercial scanning tools, they will cite some pretty sobering numbers that said, hey, of the things, 10% of CVEs are actually exploitable when they're deployed in a product in sort of the generic application case now. These are all companies that have a strong interest in making sure that you buy their very sophisticated scanning tool that can, highlight that. But I think the broad claim is understood, which is just using a vulnerable component doesn't necessarily mean that you or your users or there's national security risks. So this is a plug for an ongoing program called VEX, probably the worst named project in all of InfoSec. It's my fault. The Vulnerability Exploitability Exchange, which is very simply a way of communicating that a particular vulnerability does not affect a product. And so this is going to be, I think, very key for SBOM usage, is to say, I'm giving you my SBOM, and I'm also giving you an attestation that says, hey, this vulnerability does not affect my product. So SBOM will turn on your dashboard lights, and the VEX will help you turn them off. So, core question, why should I trust you? And I'll talk a little more about trusting SBOMs in a moment. But the trusting this, right, this is pure attestation at the moment. And I've talked to, for example, hospitals who said, yeah, we've been flatly lied to by medical device manufacturers in the past. So they can say whatever they want. We're still going to treat anything that's in their SBOM as potentially vulnerable because we don't trust their product security team. On the other hand, there are organizations that spend hundreds of millions of dollars on their product security team. Occasional mistakes are made, but you can sort of say this. And there are also other ways to supplement this. So, for example, I had a great chat with one of the founders of one of the big bug bounty programs. Hey, this is a great use of a bug bounty, which is to say, not only am I asserting this, but I'm putting a decent pile of cash behind the idea that if anyone can prove me wrong, I'll pay out. So that's the idea of VEX, and if wants to learn more, we've got an ongoing community-led effort to help develop this and refine this idea. Then, again, to Michael's point, which I won't belabor, the idea that the risk varies based on who you're talking about. So for some organizations that are trying to scale, the real risk may be less the idea that the #1 contributor to Kubernetes is Huawei, and more fundamental to the execution of my live code is a project that has a single maintainer. That could be a far more important risk to them. And so every organization needs to sort of define what the risks are. Doing that today, there are a bunch of efforts to try to think about what are some of the automated risk metrics. I don't think there's a lot of work to be done. There are a lot of folks in sort of the open source security foundation domain that are trying to figure out what are some of the other proxies, how do we apply automated scanning tools. And then there's the last piece of how do we trust? I think now is when we have to sort of cite trusting trust, and that's a box ticked for Bob's event today. We've successfully cited that. But it's a question often, yes, which is, hey, how do I trust that the SBOM that's coming to me is valid, right? So one, of course, is it signed? You know that. And then they say, well, how do you sign it? I say, well, how are you signing your code? And then they say, we're not signing our code. And I said, well, then why on earth are you worried about trusting your SBOM? But that's a different risk question. But I think it also depends on what your risk is. Are you worried about someone giving you an SBOM with a bad tool, right, or an incomplete tool? Because that's a different risk than someone lying to you. There are already some pretty strict rules about lying to the federal government about things that you sell them, but it happens. Versus the more complex SolarWinds style attack, which I think Skit is trying to sort of ultimately pull around, which is if someone has compromised my process and I can't detect it, then all the metadata that's generated by a process is pretty useless because the attacker could have compromised that. Understanding what that risk that we're facing is means that we're going to have different solutions for those.
Great, fantastic comments. I think the only additional item that I would add really is I think trying to collect the best practices that Michael talked about in terms of looking at an individual software value chain and collecting evidence along that, and then composing that into the larger system problem is really, I think, the larger challenge to be solved. Having, I guess, a perspective on the microelectronics side, I'm very much interested in kind of those boundary conditions between software and firmware and hardware. That tends to be where a lot of the interesting vulnerabilities occur that aren't necessarily easily scanned for or easily reasoned about through today's analytic tools. So I think driving scalable tools is critical to that, and then understanding really what that legacy build up to that complex system is.
That's great. I'm really glad to hear you mentioning software, firmware, and hardware. So with the increasing degrees of integration between software and devices, right? All those smart devices we're talking about, they're all driven by software. So can you share with us your thoughts on how SBOM can help with regard to that, how SCIT can help, and what the community needs to focus on to help us moving into a more secure, increasingly integrated software and physical devices world?
Certainly. I shared this morning, obviously, the software flow, but in general, the idea behind SCIT is more for a general use case for supply chains. So there is also a focus on developing a hardware use case specific for SCIT. So that would involve a very similar flow from design and EDA tools to consumption of third-party IP blocks that you would be putting into your designs, to manufacturing at the foundry, to package and test, and to provisioning those devices at the end with firmware and obviously bringing in the software component. So being able to collect those artifacts through that design and manufacturing and test flow on the hardware side, and then coupling that with the software, I think does build a rich data set from which you can start to consider kind of the system level implications and vulnerabilities that might be present, and again, assess risk based on mission and make appropriate additional steps that you may have from a customer requirements perspective.
Just a brief note on the hardware side of things. There's, I think, often been a tendency that we have a software bomb, let's have a hardware bomb, and surely they're very similar. And I'd caution us to say that they are very, very different, and there are two very critical distinctions. If I look at a piece of software and it is tested, and we sort of say, yes, we know what to do, then you can sort of verify that the next piece of software that has the same hash, it's signed, we've got a lot of integrity tools there. We do this. If I test the first smart meter, we send it up to Idaho National Labs, they've got a lot of smart people, they tear it down, they say we can trust this. It is very difficult to show that the millionth smart meter that comes off the boat is the same one as the one that was tested. You can't take a hash of a DIM. That's the first challenge. The second challenge is the semantic space, right? It is easy today to produce arbitrary signed attestations in pretty much any piece of the software world that we want. Sense making, oh, that's the hard part, right? That requires the very complex taxonomies and all the smart people sitting in rooms to say, hey, is this an edge case, blah, blah, blah. As we get to hardware, it becomes much, much harder. We don't have a global namespace for hardware. There are some advanced chips that do, but right, actually mapping the data across organizations is really hard, even inside the national security systems, right? You know, this is not my area of expertise, but I've been told that like different services use different names for hardware components, and so we don't have that. So that's it is going to be very difficult to make progress on that, and we shouldn't sort of rush to say, well, if we can do it for software, we can do it for hardware today. There's a lot of skull sweat that needs to go first.
I think I'd focus on one aspect of what I just heard, which is the word sense making. I do think that there is tremendous benefit in having an SBOM in that it exposes the chain of products that go into a critical piece of software, or firmware. But I do think we need to focus on the next steps, which is incentivizing in any way that we can the sense making of that underlying data into useful information. Off the top of my head, because I work in cybersecurity, if I start thinking with an adversarial mindset, that gives me a roadmap on how to attack any critical system if I get a published SBOM. I don't have to attack the critical system. I can go to that, that single supplier of a critical component to that system, and look to compromise that sole developer who's running off of an old computer in his bedroom as his basis, as his GitHub for this particular distro. That ability for an adversary to do critical supply chain analysis and look for innovative ways to affect a software product is a natural course of having SBOM data readily available. And I would expect over the next few years you'll see some proofs of concept from academia probably before you start to see practical uses of that. However, if you think about the mission of a test organization, I would want to stay out ahead of that and be able to translate that SBOM data into something useful to say, here is some of the risks that we hadn't considered. Package X that is fundamental to your system has a sole dependent, a sole provider for that particular software. You should consider underwriting that in some way, addressing that particular risk. But right now, from a compliance standpoint, I have a requirement to collect the data. I don't necessarily have a requirement to do anything useful with that data. And so the next step is to force, probably from compliance, but also from, with other incentives to push the development of useful, analytics for the use of that data, because certainly the folks looking to exploit that data, will come up with those tools. It's a natural course of events and is proven out by some really cool tools that I use every day. So.
And I want to very briefly respond because Michael's raised an important point that I think is true in some cases, but not in others. And you finished by talking about the tools that are already there. GDRA is free. Anyone who wants to break in to find out what is in a piece of software today can, right? You can write a mediocre SCA tool with a master's degree in software engineering. To write a good tool, you gotta have there, but there are a lot of good tools that you can use for free or you can pirate, right? Any adversary that wants to know what's in a piece of software today, if they can obtain the software, they can do that. There are some very interesting edge cases about software which we said, hey, we protect it, right? You can't really buy modern satellites on eBay, we hope. And then of course there's the cloud infrastructure side. So there are some edge cases where we can say, hey, we don't want to expose all this data. But SBOMs aren't necessary to give the attacker the roadmap. SBOMs are necessary to give the defender the roadmap.
Great discussion. With that, I would like to open up for Q&A from our online participants as well as folks in the room. I think we have some questions from online.
Yeah, let's do one online question first. How much are SCITT and SLSA interoperable?
So they're certainly interoperable. So SALSA is really more about just providing a scoring mechanism, and that is really based on kind of an independent tool entirely, but SCIT is really more just about the collection of the evidence from that comprehensive end-to-end supply chain and applying policy based on that evidence. You can still store potentially and SALSA score as part of that. That might be a piece of evidence you'd like to distribute with the SBOM and your package. So I'd say they're compatible in that regard.
All right.
I was wondering if you guys could discuss the kind of paradox of mandating SBOMs and the fact that obviously you get to critical mass faster if everyone has one, but on the downside, you're kind of locking into place what an SBOM is and how it's used if you mandate it now and you come up with rules for it. And you lose out on some of the benefits that you guys are talking about for the future. So just wondering what you guys think about the idea of mandating them.
I would say, I guess, from the IETF perspective, I think the SBOM is a good tool for just internal use for companies to use. Whether or not they choose to share it is really up to them. From the SCIT architecture perspective, we fully understand that an open source model is much different than something that may have protected IP in it. And there's going to be instances where the SBOM is not something that is transparent and available to the public to consume. There may be NDAs required. There may be special use cases like working with the government where you do need to provide that SBOM. But in general, there's going to be a hybrid use case of security around what artifacts and what SBOMs are shared in an open sense.
It's a fun question and one that, of course, we wrestled with. I'll try to sort of answer very briefly, which is one, sort of the minimum elements that were published at the request of the White House in July of 2021 make it clear that this is the elements at that time. And in fact, we expect the set of what constitutes an SBOM to increase. So the challenge then is to say, hey, how do we make sure that we're not changing what the internal tools was? Because Michael said, hey, you know what, we're already collecting this data. And so I'll give you a very quick example of what, something that didn't make the threshold in 2021 was hash, right? Pretty obvious for any software supply chain discussion is they give me the hash of the component. The challenge was in 2021, we didn't think that there was sufficient uniformity of exactly how to take the hash, which algorithm to do, how do you handle the awkward edge cases around directories and things like that. And so there was a real risk that we had learned through experience that multiple tools would look at the same piece of software and produce different hashes, which is contrary to the whole purpose of taking a hash. So over time, I think we're going to see, and both on the implementation side, at the high level side, there's been some great progress. So I think we are going to see improved clarification on, hey, how do we expand this? And I don't think that's going to be that disruptive because, again, all of this stuff is sort of generated by tools either in the build process or through binary analysis type tools.
From an implementation standpoint, I think implementing something sooner, aids you in being able to make a more accurate assessment. The requirement for SBOM gives me a standardized set of tools to be able to measure the security of disparate systems, because there is now a common piece of information that I can analyze. More information is generally better from a testing standpoint. From a cybersecurity standpoint, we're not dealing in absolutes. One of the earlier questions walked through measuring against a particular standard. For in that case SQL. Generally speaking, we're in the cybersecurity realm. You're not dealing with absolutes. You're measuring risk. What is the risk of deploying this particular system in this context? The answer for a system that's locked in a room somewhere and doesn't interact with the world will be different than the answer I might give to a system that is highly interconnected and is critical to some business function. Publishing sooner, gives another framework for making good security decisions. So I'm very happy with the deployment of of SBOM, but am looking forward to the analytics that I expect to see that are going to help me do this sort of analysis at scale.
Well, I'm giving the finger from Bob. So let's if we can. Is this a real quick question?
I'll make it quick. So I'm Bob Metzger. I'm a consultant to MITRE, among other functions. Hello. Cross-domain solutions. So you're starting with unclassified participants in the development of complex software for national security purposes. And you're expecting to have a cloud host and to escalate the software from build teams that may use open source components and involve many persons without clearance, but you're going to migrate it up to secret or top secret or beyond. In that context, are SBOMs helpful to you, or do they become their own vulnerability or a roadmap for a clever adversary to find a way to insinuate itself into the ultimate product and degrade the system?
I'll take a swing at that first, because that's not a known use case for me. And first, it's definitely a benefit. One of the standard rules are, for that sort of scenario where you're moving from a lower classification to a higher classification, is some analysis of the product by someone who is knowledgeable on the intended use case. That could be as simple as someone with an appropriate clearance that says this is going to run into, in this classified environment, vice the internet. Or it could be someone very familiar with the mission. Ideally, it's both. Again, what an SBOM does, it gives you insight into the composition of a particular piece of software. And much in the same way a source code analysis tool is going to tell you, is going to tell you where the buffer overflows may lie. An SBOM is going to give you insight into what software is being deployed into that particular environment. Used properly, it's going to help those folks doing that analysis make better decisions. It may be this is not appropriate for this particular environment, or it may be the open source products that compose this are adding to the security given our given use case. I've seen both scenarios in practice based on selected software packages. But being able to look at that in a continuum, to be able to understand the dependencies of some of the software that I depend on, I think that's a very good thing. So I think an SBOM in a multi-level security environment is an incredible enabler.
Okay, well, thank you. That was a comprehensive answer. I guess our other two panelists agree. So with that, let's thank our panelists for this sharing with us on their great insight. Thank you very much.